Okay, so I'm Joe and I'm a RA from the University of Bristol Cybersecurity Group, and this is Going 20 Seconds, an overview of a password vulnerability in Siemens HMIs. This is work I've done with Awais, Rashid, also at Bristol. So to get right into it, so the Siemens HMI range is a range of human-machine interfaces, and these are the physical screens that are located next to the physical processes in order to interact with that process. So they display information about the process and let you set inputs to the process. We see two sort of ranges of devices that Siemens make. There's the basic range, which you can see in the top left up here. These are Linux-based devices, and these are the cheaper versions, which you can see at the top left here. This is the Siemens KTP700, running inside one of our teaching boxes. And you also have the advanced range, which includes the comfort range and the wireless range, and these are all Windows CE based. So the two examples here, this is the TP1500 up the top right, and this is a wireless panel that we use in our testbed on the bottom. They are virtually the same, other than the advanced panels have a few extra features. They have more memory. You could do nicer looking displays on them, but they are basically the same products. One of the features that comes with these is the smart server and smart client applications, and these are used for remote maintenance and control of these HMI panels. So this comes installed on all of the devices they sell, although on the basic panels you have to pay an extra license fee to be able to use it without annoying pop-ups every 10 minutes. But these aren't turned on by default. You have to actually activate them into your portal, and then you go configure them on the device. So there's two parts to this. There's a smart server application, which is installed on the HMIs. This is basically a VNC server, and this is entirely configured on device. So you activate it onto your portal, and then you do all the settings on the device itself. And we see two versions of this. So we have the version on the basic panels, which you can see in the bottom left picture here. This is over the remote connection to a KTP700. Set in settings, and also you have the settings on the advanced version, which is slightly different. It has a few more options, which you see on the bottom right. To go with this, there's a smart client application. So this is basically a VNC client that you can get for Windows, Android, and iOS, and you can see that at the top right. This gives you a visual representation of how HMI looks. So this looks like just like a KTP700, and it also does map the physical buttons as well. So there's 8 physical function buttons on a KTP700, and you can use the remote client to control these. As it does run VNC, you can also use third-party VNC clients as well for a reduced experience, but they do work. So the vulnerability. So what we found with their experimentation was that Smart Server has insufficient protection against brute force password attacks. On the basic panels, there's no prevention at all. You can guess as much as you want. There is a prevention mechanism on the advanced range, but it's quite easy to evade. This isn't a groundbreaking end of the world type of vulnerability, but it does show some very poor design choices and how they set this up, and kind of shows that there's still these very basic vulnerabilities that exist on these devices that aren't being discovered. So set up for the demo. So we have a basic virtual process, which is Factor.io. You can see at the top right. This is just to give us some data to display on the screens. We're using a MikroTik router for network communication, and a Siemens S7-1200 PLC control, which is inside our teaching box here. They're using 2 HMIs for this demo, both connected to the same PLC. We have a KTP700 basic panel, which is running firmware version 15.01. And a TP1500 comfort panel, which is running version 15.1 as well. Both panels are connected by Ethernet to the switch and to the PLC, and both run exactly the same program. I just converted the program from the 700 to the 1500, so it's running the same code, basically. So just to show how the normal smart server operation works. So this is an example here. So you can see a recording of the HMI at the bottom right, and this is a smart client application in the middle on top of the portal. So enter the IP. I've already set a password on the smart server, and then we connect, and you can see that the screen for the physical device is matched onto the virtual device on smart client. And as I push the button on the remote screen, then the actual physical HMI shows where I clicked and updates. You can also use third-party VNC clients, such as using VNC Viewer, which comes with Kali. So you enter the password and you get a reduced experience. So you see here, it doesn't map the physical buttons around the edge. You just get the screen itself. So if you do connect to a screen with physical buttons, you can't use them over VNC connection. So for our attack assumptions, we assume that smart server has been configured and is turned on, and a password has been set. You can't actually set smart server without setting a password, even though there is an option for an empty password. It doesn't actually run if you don't set a password. I must assume the attacker has network access to the HMI panel, so they have got a connection somehow to be able to connect to VNC to that device. So to attack the basic HMI panels, we're simply going to use Hydra, which is a password cracking tool as well, pretty standard tool to use because of Kali, and this is the GUI version. I've set it to attack a VNC protocol. using 4 threads and give it an IP address and a password list. And it does roughly 4 guesses every second, and you can see it guesses through here, and then it finds 3 successful passwords: security, security 1, and security 3. I'll explain why it's finding 3 in a little bit later, but the basic one we can use is security. So we go back to Smart Client, type that in as the password, and then we should get a connection to the HMI from there. So what about those advanced panels? So if we try and use Hydra on the advanced panels as well, after a few guesses, we start getting these VNC server connection failed messages come out after about 5 or 6 guesses. For a bit of investigation, I found that these were the VNC server actually rejecting the connection, not even doing the authentication step. It just flat out refuses the connection from there. And with a bit of try and error, what we found was that this is the brute force protection mechanism of the advanced panels. And each IP address can make 5 incorrect guesses and then gets locked out by IP address. You can then switch to a new IP address and then make 5 more guesses, and then you get locked out of that address as well. But if you then wait 20 seconds and go back to the original IP address, you can then make 5 guesses again. And after 20 seconds then, you can go back to your second IP address and make 5 more guesses, and basically switch IPs and continue making guesses at a very slow rate as long as you want. We did try just making 5 guesses and waiting 20 seconds. That doesn't work. You have to switch IP addresses and make those guesses, 5 failed guesses first before you can return to the original IP address. So I left Hydra alone there and put a little basic bash script to do this in order to switch IPs and use the VNC viewer client to try and connect. Yeah, so this is 2 IP addresses, and it's making 1 guess every 4 seconds with 2 IPs, .51 and .52. So as you can see, it's quite slow. It's a very slow rate of guessing compared to using Hydra on the basic panel. I do speed this up to show it working. So I had 5 guesses, switch to IP52. We then make 5 more guesses, and then we switch to IP51 at the end, and we can make 1 more guess. This is very slow, but I found that if I move up to 4 IP addresses, I can reduce that time between guesses down to every 2 seconds, because I can make more guesses, more IPs before I return to the original after 20 seconds. So again, I flip between the different IP addresses, 51, 52, 53, and 54, and then can return to IP address 51 at the end and make some more guesses and keep going. And finally, I tested with 8 IPs. This is the most I went up to, but theoretically you could go to any. And this goes to a guess every half a second. And I'll leave this to run until it catches the password, which happens to be in the list, fairly close to the top. And you'll see once it finds the correct guess, it will automatically open up the VNC connection, and then we have the screen, and you can see the password here as we printed out security again. So that's the attack. But what about the sort of impact of that attack? And one of the particular things we noticed with this was, with the smart server, is that by default on the Siemens HMI screen, the programmed view, you get this button in the bottom corner, which closes the runtime and lets you go out to the settings menus. And one of the settings you can get to is the smart server settings. And one of the settings of smart server is that you can disable the local input on the screen while you're connected over a remote session. So the touchscreen itself locks out, and so only the remote connection can control that screen. So when you show the setting, it has to restart the smart server, but then it sets itself back up again instantly. You get disconnected, you reconnect. I've now reconnected, and I can control it and start pushing that pusher as much as I want over the remote connection. Our engineer sees things go wrong. He goes to the screen and tries to stop the process running. As the touchscreen, it no longer works. You can see in the bottom left, the buttons are completely locked out. They can't do anything on that screen. And the further issue that we found was related to how VNC handles passwords. So most VNC implementations only support passwords of 8 characters or less. And Smart Server uses type VNC for its connection. The VNC clients will truncate passwords that are greater than 8 characters long. So it means that if you set a password that is 8 characters and you use a third-party VNC client to connect, you can successfully authenticate with passwords longer than 8 characters as long as the first 8 are correct. So if password is set, password 1 will authenticate, password exclamation mark will authenticate, which basically makes guessing a bit easier because you have a larger search space you can use to get the right password. This isn't an issue with the smart client itself. The smart client does support longer passwords because it uses a different authentication method to standard VNC authentication. But the smart server, when you set a password, actually actively discourages you from setting a password longer than 8 characters. And you get these error messages come up, as you can see on the screenshots there. So you're encouraged to set that shorter password. So finally, the response to this. So from our side, the suggested mitigations are if you can disable smart server or don't activate it if you're not going to use it. If you have to set a password, set as secure an 8-character password as you can get in that. It is quite difficult because these touchscreens are very bad for typing on. In short, different HMIs have different passwords. Configure firewalls to limit access to VNC connections, patch your devices, and configure your IDS to look for large volumes of failed VNC connections. And finally, we disclosed to Siemens in February this year, and they issued the CVEs in September this year. So there's two assigned CVEs, CVE 2020-15786, which is the insufficient blocking of brute force password attempts, and CVE 2020-15787, which is a very particular password truncation issue they discovered themselves on the United Comfort panel range, but not the generic VNC issue that I just described then. This is all described as Siemens Advisory 542525, and they are planning to release a patch according to that advisory. So thank you. Happy to take any questions. There is a full technical report available on archive. The link there is also linked in the extended abstract for the talk. You can also send me questions on email at joe.gardiner@bristol, and I am on Twitter. You can DM me on there as well if you have any questions. Thank you.